You can also solve this problem using Squeeze Theorem. So a Squeeze Theorem say that if you can sandwich this function between two other functions with no limit, then the limit of this function is going to be the same as the limit of those two functions. Okay, let's take a look at this. From algebra, guys, there is nothing calculus about this. Absolute value of x cubed y squared divided by x squared plus y squared, this guy is always positive, is always larger than or equal to 0. And it's always less than or equals to absolute value of x cubed. Why is that? Take a look at this. If you have any fraction, a squared divided by, for example, a squared plus b squared, from elementary algebra. This is a fraction like 1/3 or 1/4, 2/5, anything. These fractions are always positive and they are less than or equal to 1. We can always sandwich these fractions like this. That's the basic numerical relations, all right? So this fraction can be always sandwiched between, oh, my smiley face, 0 and 1. So very good. Now I can multiply this inequality by something else. If that is positive, it doesn't change the order of inequality. So let us multiply by any positive quantity. For example, if you multiply this guy by m squared, 0 is less than equals to m squared a squared divided by a squared plus b squared, and it's always less than or equals to m squared. Well, you could use the absolute value to make sure it's positive. So if I multiply this guy by absolute value of m cubed, it makes me to multiply my inequality by a positive quantity because of absolute value. It assures, it guarantees that this guy is always positive. So absolute value of m cubed, and it's going to be less than or equals to absolute value of m cubed. We're doing the same thing here. What do we have? We have y squared divided by x squared plus y squared. And then if you multiply that by a positive quantity, like x cubed, absolute value of x cubed, then you have the following scenario. You have absolute value of x cubed, y squared divided by x squared plus y squared, which is less than or equals to absolute value of x cubed. Well, okay, now we can take the limit of all sides. As x and y approaches 0 and 0. The limit of 0 is just going to be 0, all right? X goes to 0, y goes to 0 is less than equals to the limit of this function that you're trying to find, its limit. Plus y squared as x goes to 0, y goes to 0, which is less than or equals to the limit of absolute value of x cubed as x goes to 0, y goes to 0. There is no y here, but we're going to write it down for the sake of the limit. This is 0. This is also 0. What's the meaning of that? By Squeeze theorem, the limit of the middle function is also 0. So by using the squeeze theorem, the limit is going to be